Hello everyone, I am Bipul Kumar Sinha, PGT Chemistry of Janvi North Tripura. I welcome you in chemistry class. Today we will take up the solid state from class 12 and the topic would be the solids and their classification. Welcome students, today we will take up the solid state. As in a student, the matter can exist in three different states: the solid, liquid, and the gases. And you know the properties of solid. Solid have the fixed shape and the fixed volume. Solids are rigid. Solids are incompressible. Solids have slow diffusion, and the solids have high melting point and the boiling point. So these are some of the properties of the solid, and we'll move to the next topic. Our next topic is the classification of solid. So here you student, that here the classification is here based on the nature of arrangement of the constituent particles. Based on the arrangement of the constituent particles, the solids are classified into crystalline solid and amorphous solid. So we will now discuss about the crystalline solid by taking the example. One of the example of crystalline solid is the sodium chloride. Here sodium chloride is made from sodium ion and the chloride ion. So let us look at the arrangement which is there inside the sodium chloride. Inside of the sodium chloride, sodium ion, chloride ion, sodium ion, chloride ion, we can see the arrangement. So if we look at this arrangement carefully, we can see that the constituent particles have a regular arrangement. Okay, if we move from left to right or from top to bottom, wherever you can move, you can see that arrangement is regular. So we can say such kind of crystals will be called as the crystalline solids. So the crystalline solids are those where the constituent particles have the regular arrangement. On the other hand, the amorphous solid. In amorphous solid, you can say in here the constituent particles do not have the regular arrangement. One of the example of is the glass. You may be surprised that the glass appears to be smooth, but how can it is a amorphous solid? Okay, well, if you break a piece of glass, the new surface that will appear, okay, for a small range it will appear smooth, but entirely the new surface will be a rough. So this rough appearance of the glass surface shows that the constituent particles of the glass are not regularly arranged. That's why glass is an example of an amorphous solid. Now students, let us have a look on the differences between crystalline solid and amorphous solid. The basic difference between amorphous solid and crystalline solids are that amorphous solids do not have an ordered structure, whereas crystalline solids have an ordered structure. Amorphous solids do not have a sharp melting point, however, crystalline solids have a sharp melting point. Amorphous solids have no characteristic heat of fusion, but the crystalline solid have a definite heat of fusion. Amorphous solids are isotropic since they have the same physical properties in all directions, whereas the crystalline solids are anisotropic since their physical properties are different in different directions. Amorphous solids have covalently bonded networks, whereas the crystalline solids have covalent bonds, ionic bonds, and van der Waals bond and the metallic bond. Let us now discuss about the crystalline solids. Crystalline classification of crystalline solid. Crystalline solids are classified into ionic solid, covalent solid, metallic solid, and molecular solids. Now we'll discuss these four different types of solids with the help of examples. The example of ionic solid is sodium chloride. Sodium chloride is made between sodium ion and chloride ion. Here the constituent particles are the ions, and the interactive forces present between these between the ion is nothing but the ionic forces. Hence, the solids where interactive forces are the ionic forces are called ionic solids. Covalent solid. Diamond is an example of covalent solid, and diamond is the allotrope of carbon. It is in diamond, one carbon is covalently bonded with four other carbon atoms. So here the particles are here, the atom, and the interactive forces is the covalent forces. Now, metallic solids. Uh, Iron is an example of a metallic solid. In iron, the constituent particle is the iron atom, and here the interactive forces is nothing but the metallic forces. So the solids where in internuclear forces or the attractive forces or metallic forces are called the metallic solids. Molecular solids. One of the example of molecular solid is the ice. Ice is the solid form of water. In ice, the water molecules are held by weak force such as the hydrogen bonding. So, the solids in which the attractive forces is the weak forces such as the van der Waals forces of attraction, hydrogen bonding, etc. So, such kind of solids will be called as the molecular solids.